Hi everyone. Today we'll discuss rational root theorem. What is rational root theorem? A naught x to the power of n plus a1 x to the power of n minus 1 plus so on an equal to 0. So to find the possible roots of the equation, possible roots, the constant by coefficient of x to the power of n, constant by a naught plus or minus. These are the possible roots. So the roots are many, but what we will get here according what suppose x to the power of n is there. Suppose x to the power of n is n possible, n roots will be there. Possible may be as many as may can be. Let me give, we will discuss one problem one by one. We will discuss. Suppose find the roots of quadratic equation x square plus 5x plus 6 equal to 0. This we are finding the quadratic roots. So what is the coefficient of this leading coefficient? This is a naught is leading coefficient. Leading coefficient. So constant by possible roots are plus or minus 6 by 1. What are the roots of 6? 1, 2, 3 and 6 is there. And plus or minus. And 1 is plus or minus 1. So 1 by plus or minus 1. So this will be plus or minus 1, plus or minus 2, plus or minus 3, plus minus 1, 2, 3, 4. So possible roots are 8 roots are possible roots. But we know it is a equation of quadratic equation of degree 2. So it will have only 2 roots. So what is our required root? We require only 2 roots. And that 2 roots will be from here. What are they? That is the big question. What are they? That we have to find. So we are going by the synthetic division method. So for synthetic division, the coefficient of x square is 1, the coefficient of x is 5, and the constant is 6. We have to write 0, this is equal. So I am taking x equal, all are positive, so I am taking x equal to minus 2. Minus 2 times 1 is minus 2, 5 minus 2 is 3, minus 2 times 3 is minus 6. Minus 6 plus 6 gone. Now again, suppose if I take x equal to minus 3, 0 plus 1 is minus 1 time plus 3 is minus 3. So gone, minus 3 plus 3. Therefore, the roots are x equal to minus 2, minus 3. Two roots because it is a quadratic equation of degree 2. The roots may be rational or irrational. So I have taken the simple example to show that the roots are real roots I have taken. So one more example. See, one more example. See here. One more example. Simple case I will take. Simple case I will take problem. Solve or find the possible roots of 4x square minus 8x plus 3 equal to 0. So solution, possible roots. First, possible roots. Possible root is constant by coefficient of leading term. Constant is 3 plus or minus. Coefficient of leading term is 4. So these are there. Now factors of 3. 1 and 3. And factor of 4 is 1, 2 and 4. So this will be plus or minus. So what will be the possible roots? Possible roots is, if I take plus 1 by 1, plus 1 by 2, plus 1 by 4. And if plus or minus, we will take both values. Now if I take 3 by 1, plus or minus, then plus or minus 3 by 2, plus or minus 3 by 4. But these are possible root. 1, 2, 3, 4, 5, 6. 6 times 2 is 12 possible roots are there. 12 possible roots. But what is our requirement? It is of degree 2, so we should need 2 roots only. What are the 2 roots? We don't know. It is from this. So that we are going to find. So our problem is 4x square. So I am writing the 4, then minus 8, 3. And this by synthetic division. This will be 4. Now what we have to take? You see, if I take x equal to 2, it will not fall. So what I am taking? X equal to plus 3 by 2. So 3 by 2 into 4. How much? 4 into 3 by 2. 3, 2 ones are 2 twos are. 2 times 3 is 6. So 8 minus 6 is 2. Now this thing 2 times 3 by 2. 2 to getting cancelled and this is minus 2. So this will be minus 3. Plus 3 minus 3 it is 0. Now I am getting 4. So I want to take x equal to I am taking 1 by 2. 1 by 2 times 2 is 2 plus 2 minus 2 is 0. So therefore possible roots, not the required roots are 3 by 2 and now. Some teachers say required roots, some they say 0 of the polynomial are the same. You can say the roots are the zeros. Zeros means if you put 3 by 2 in the given equation, it becomes 0. Both the ways is right. Different way of saying. So the required roots is, you see, now this time we got the rational root 3 by 2, 1 by 2. This is the simple case I have taken. Now I'll go with a little bit higher one. Little bit higher one. See here, this one. Problem number 3. Suppose find the possible roots of find the possible roots of x to the power of 4 minus 16 equal to 0. This. So what is possible roots? Possible roots. Possible roots. Constant by leading coefficient in 1 plus or minus. So what will be the roots? 1, 2 is the factor. 1 times 16 is 16. 2 times 8 is 16. 3 will not go. 4 times 4 is 16. 5 will not go. 6 will not go. 7 will not go. 8 times 2 is 16. 9, 10, 11, 12, 16 times 16. These are the possible root with plus or minus. So 1, 2, 3, 4, 5. 5 into 2 is 10 possible roots are there. But what we need only 4. The power 4 is there. So write the synthetic division. You see x to the power of 4 coefficient in 1. No x cube, no x square, no x, only the constant term. So minus is there. So I will take plus. I will take plus x equal to 2 I will take. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. 0 plus 4 is 4. 2 times 4 is 8. 0 plus 8 is 8. 2 times 8 is 16. So plus 16 minus 16 gone. So x equal to 2 is the root. Now everything is positive. Let me try with the negative 2. Minus 2 times 1 is minus 2. Oh, minus 1 2 times is minus 2. So plus 2 getting cancelled. 0 minus 2 times 0 is 0. So this is 4. Minus 2 times 4 is minus 8. So now minus 2, 2 we got 2 root. 2 more roots is there. You see, one root is gone means the equation reduce power 4 is there. If you find one root, it will be power 3. If you find one more root, it is power 2. So this will be x square 0x plus 4 equal to 0. So now, so x square plus 4 equal to 0 or x square equal to minus 4, rooting both the sides, x equal to plus or minus 2i. Therefore, required roots are plus or minus 2 and plus or minus 2i. You see here, we have done possible roots. There is no imaginary root here, but we got in the answer imaginary roots. So this condition is just the necessary. not sufficient. The root may come outside our possible roots also. This is the example we have done. So one more problem we will do another time. So x to the power of 4 minus 4x square. No. X to the power of 4. Solve. Find the roots. X to the power of 4 minus 13x square plus 36 equal to 0. This is the root. Find the possible zeros or roots. So this is possible roots will be 36 by leading coefficient 1 plus or minus. So 1 is 2 18s are 3 1s are 3 12s are 4 9s are 36 uh, 10 11 no 12 3s are 36 12 13 13 13 or 14 15 16 17 18 18 ones are 18 18 twos are 36 possible root 18 no other no 36. These are the possible roots plus or minus, but required root is our requirement is we want only 4 roots. So we will go by synthetic division method to find what are they. What are that 4 roots? So let me write it down. Synthetic division. X to the power of 4, coefficient in 1. No x cube, 0. Coefficient of x square, 13. No x, 0. Then constant is 36. You see, I am going with x to x equal to 2. I will go. 1 times 2 is 2. 0 plus 2 is 2. 2 times is 4. This is minus my 2 times 2 is 4. This is 13 minus 4 is 9. 2 times 9 is minus 18. So this is minus 18. 2 times 18 is minus 36. Gone. So x equal to 2. So you see it is looking like minus 2. Let me change it. Let me write it properly. So this is x equal to 2 we have taken. Now I will take x equal to 3. X equal to minus 2 I will take and see. Minus 1 times 2 minus 2 plus 2 is 0. 0 times 2 is 0. Minus 9 minus time minus is minus plus 18 minus 18 is gone. It is 0. Now take x equal to 3 I will take. 1 times 3 is 3. 0 plus 3 is 3. 3 times 3 is 9. Plus 9 minus 9 gone. So now x equal to minus 3 if I take. 1 time minus 3 is minus 3. Plus 3 minus 3 is not. So for the required roots, what we got is plus or minus 2 plus or minus 3. So 4 roots. We required only 4 roots. So x equal to number of the zeros are plus or minus 2 plus or minus. And one more thing here, sir, we are going with the 2. You can go with the 3 also. There is no rule that you have to go. But the what our teachers has taught us, go with the simple number first, then go with the big number. That's why I have gone with the 2. If you go with the 3 also, you will get the same. So, and this all the problems what we have done here is leading coefficient is unity. You see all the problems we have done, the leading coefficient is unity. So one more problem, x to the power of 4 minus 10x cube plus 35x square minus 50x plus 24. Find the possible roots. Find the possible roots of. So x to the power of 4. What is this thing? Possible roots are plus or minus 24 by 1. What are the factors of 24? 1, 2, 3 8 is 24, 4 6 is 24, 5, no, 6 3, 6 4 is 24, 7, 8, 8 3 is 24, 9 1 is 9 2 is 18, 12 2 is 24 and 24 itself. So plus are 1, 2, 3, 4, 5, 6, 7, 8. 8 to the 16 possible roots are there. 16. 16 possible roots. But what required roots are? Required roots are, we want only 4. So let's go with the synthetic division and find the roots. You see, some teachers, they go by putting x equal to 1 and trial and error method. That sometime if we do a small mistake, that will be a problem. So I prefer synthetic division method. It's up to you, whichever you feel you can go. So writing coefficient minus 1, 10 cube, 35, minus 50, 24. You see nothing is 0. X power 4, power 3, power 2, power 1, 0. 5 terms. 1, 2, 3, 4, 5. Now let me go with the small number x equal to 1. 1 time 1 is 1. Minus 10 plus 1 is 9 with minus sign. 1 time minus 9 is minus 9. This is 26. 1 time 26 is 26. 50 minus 26 is minus 24. 1 time minus 24 is minus 20. Minus 24 plus 24 gone. Again we have to go x equal to 1 we have taken. I will take x equal to 2. 1 times 1 plus 0 is 1. 2 times 1 is 2. So minus 9 plus 2 is minus 7. Minus 7. 2 times 7 is 14. Minus 14. So this is 12 plus 12. 2 times 12 is 24. Plus 24 minus 24 gone. Now let me take x equal to 3. 1 times 3 is 3. Minus 7 plus 3 is minus 4. 3 times 4 is minus 12. Minus 12 plus 12 is gone. Now take x equal to 4. 1 times 4 is 4. Plus 4 minus 4 is gone. So that's it. It should be, there will be one constant. 1, 2, 3, 4. 4 times we have done. So what are the roots? Required roots. Required roots of the given polynomial is x equal to 1, 2, 3, 4. That's it. That is our answer. Now, one more problem I will do. That problem is, you see, we have done almost all the problem where leading coefficient is unity. Now, I will do the problem where leading coefficient is not unity. 2x to the power of 4 minus 9x cube plus 14x square minus 9x plus 2 equal to 0. This we have to solve or find the possible roots. So possible roots is, what are possible roots? Possible roots is plus or minus coefficient of constant by coefficient of leading term. Constant is 2, 2 by 2 plus or minus 2 by 2. So this will be plus or minus 1 is coming. So the roots are, it is showing the possible roots are plus or minus 1. Only 2 roots it is showing. But our problem required 4 roots, you see, power 4. Power 4 means we need 4 roots. So possible roots are these. So required roots are 4. And we don't know, we got the clue as plus or minus 1. Let's go and see. Go with the synthetic division. So write the synthetic here, coefficients of the given problem. 2, minus 9, 14, minus 9, 14, minus 9, 2. So let me go x equal to 1, we will go with the plus 1. 1 times 2 is 2, minus 9 plus 2 is minus 7. 1 times 7 is 7, minus sign, this is 7. 1 times 7 is 7, 9 minus 7 is minus 2. 1 time minus 2 is minus 2, plus or minus, gone. So now again I will take repeated root, I will think and go 1 time 1 is 1, minus 7, 1 is minus 6. 1 time minus 6 is minus 6. Oh, I am sorry. This is 2. This is 2. So 1 times 2 is 2. 7 minus 2 is minus 5. 1 time minus 5 minus 5. 7 minus 5 is plus 2. 1 times 2 is 2. Plus 2 minus 2, gone. Now I will take 0. This is 2. I will take x equal to 2. 1 times 2 times 2 is 4. Minus 5 plus 4 is minus 1. 2 times minus 1 is minus. Plus 2 minus 2, gone. 0 to what shall I take? It should be 1. So I will take 1 by 2. 1 by 2 into 2 is plus 1 minus 1, gone. So therefore possible roots are 1 plus or minus no possible repeated roots. 1 is repeated. So this is 1, 1, 2, half are the required root, are the required using rational root theorem. We have done. I made two videos. One video I shown that the rational root theorem can be used to any power. I have used the power 10, x to the power of 10 polynomial. So big polynomial, and I have shown that it can be done very easily by using two properties. Rational root theorem, finding the roots, what are the required roots, then solving by synthetic method. Another video is there. If you want, you can see that video just for seeing how beauty of the synthetic division and rational root theorem. Such a big problem you can solve within no time. Please subscribe my channel for more upcoming videos. If you like the video, please do share. Thanks for watching.